here. And I'll upload this to YouTube right after. But today is going to be a midterm review. And the way that that's going to happen is I just brought the midterm from last fall. It's going to be very, very similar. Of course, it's not going to be the same questions. But I do provide a little bit of starter code sometimes. And that year I provided some starter code via GIST. Last year, of course, it was timed, so you had to be done within the hour and 15 minutes that you had. But of course, on Wednesday, I will post it in the morning. You'll have all day to do it until midnight. It's still designed to be done in about an hour and 15 minutes, but you should not take that as I will start at 11 p.m. Start as soon as you can. Once it's released, you can submit and resubmit as many times as you want. Of course, absolutely no collaboration of any kind. I don't want to see anything on Discord. No publishing of code on Discord or Piazza or anything else. You can, of course, ask questions during office hours, general questions, but we're not going to give you the same level of help as we give you on Labs and Hacks. So, as a review, any questions on that first of all? Otherwise, as a review here, we're just going to do as much as we can, and we're going to do the entire thing of the midterm from last year. This link is no longer live, but I've got the files set up over here. We were given a bunch of files here as starter files. So the first one is Fizzbuzz. So in case you're not familiar with Fizzbuzz, I did it in the videos. It is a classical problem. It is basically an interview weed out question. If you look at the article that I posted on Canvas under suggested reading, this is one of them. Why can't programmers program? And it's industry folks lamenting the fact that they'll get people with resumes with 4-year, I have 10 years experience, or I have a degree, and so I'm able to program. But yet, if they just give them the simple program, and it takes them more than 20, 30 minutes, or they can't do it at all, they know that something's wrong there. They know that they either cheated their way through a degree program, or that they're just lying on their resume. It's something that you should be able to do in the first 3 weeks of a Computer Science 1 course. The classic example is that you need to print out the numbers 1 to 100, 1 per line. Except if the number is divisible by 3, then you have to print out Fizz. If it's divisible by 5, then you print out Buzz. Otherwise, if it's divisible by both, 3 and 5, then you print out Fizzbuzz instead of the number. This one is a little bit more general in that you're given those values as parameters. Write a program that takes 4 integers, a, b, p, and q, as command line arguments, and prints the numbers a through b inclusive on both. So if a is 1 and b is 100, it's the classic Fizzbuzz problem. We're going to print out 1 through 100. And then p and q, if the number is divisible by p, then we print out Fizz. In other words, if it's divisible by 3, then we print out Fizz. If it is divisible by q, then we print out Buzz. If it's divisible by both, then we print out Fizzbuzz. Okay? Simple enough. Again, this is a weed out question in a lot of interviews, or something like it. Right? So first of all, we will be grading on documentation, on style, on design, on everything that we've graded on as far as your hacks go. So make sure that you've got all that there. Header documentation, of course, would be author, date, it's the 5th, and the purpose of the program. This is a generalization of the classic Fizzbuzz program. Right? That prints out numbers or A through B, whatever. You can put in more details there if you want. All right. To do, implement. So if I'm going to be reading stuff as command line arguments, as this example shows, that if you're going to run it as a.out, then you provided a, b, p, and q. That means that I need to be reading them in as command line arguments. Design is graded, therefore I need to make sure that I am doing basic error checking. How many command line arguments am I going to expect? A, B, P, and Q, and the actual executable file name. So I'm going to be expecting 5. And if I don't get 5, if it's not equal to 5, then I will print an error message, provide A, B, P, and Q. And then quit on them, right? Exit. Otherwise, if I am given those 5 elements, then I need to convert them. I need to convert the first one to an integer, the second one to, in fact, they're all integers, right? So I will create int A is equal to, int B is equal to, how do I convert integers? A to I of argv sub 0. Is that the first one? Technically, it's the first one. But is that the first one that I want? No, that is the executable file name. So a argv sub 1, 2, 3, 4. May not necessarily want to do copy pasta, but I'll do it here. Right? A, B, P, and Q. Right? Just like I wanted over here. Now I need to print out numbers A through B. Well, that's do we want to use a for loop or a while loop? A for loop, okay. Print for int I equals 0. I is less than 100, I plus plus, right? Or less than or equal to. If this were the classic Fizzbuzz problem, then I would hard code those values to 1 to 100. But this is not the classic Fizzbuzz problem. This is a generalization of it. Where should I start my value? A. Where should I end my value? B. Okay. And I'll printf %d and the line I. Make sure it works. Intermittent, check sanity checks and stuff like that. Fizzbuzz. Oops, I need to go into, where am I? GCC Fizzbuzz. There we go. All right, so error provide A, B, P, and Q. Okay, let's just try it with the classic Fizzbuzz problem. 1 to 100 and 3 and 5. Right? There, it prints out numbers 1 through 100. Right? 1 through 100. But what we need to do now is we need to short circuit that. And we need to say, if it's divisible by 3, then print fizz instead. Or if it's divisible in this case by P, then print fizz. How do I check if something is divisible by P? If I is divisible by P. Well, how would I do it if it were 3? I divided by 3 would have a remainder of 0 if it were divisible by 3. In which case I would print f fizz. Else, print this guy. Print the number. Now, I want to generalize this, so it's not 3, it's going to be, I think it was P, right? P and then Q, in order. Find your P's and Q's. Right, there we go. Right, P, then print fizz. There we go. Just have to look at the directions again. Else if, or should I do another if? If I is, I divided by Q is 0, then I should print buzz. Should I do 2 separate independent if statements here? I only want one of these things to happen. And if I only want one of these things to happen, I need to make them mutually exclusive. Mutually exclusive means that I would be using an else if, and then an else. Okay? So if it's divisible by P, then fizz. Otherwise, if it's divisible by Q, then buzz. Otherwise, if it's divisible by, not divisible by either one of them, then print the number as usual. But what do I do about that last case? If it is divisible by both P and Q, then print Fizzbuzz instead. Where do I put that? Should I put that down here? Else if I is divisible by both, then print f Fizzbuzz. There we go. Else print that. Well, let's think about this in terms of the classical Fizzbuzz problem. Say that I get up to 3. That's not divisible by 5. 5 is not divisible by 3. But ... When I get up to something that is divisible by both, what's the first number that's divisible by both 3 and 5? 15. Right? So something is divisible by 3 and 5 if it is divisible by 15. So one way of writing this is I mod 15 as a remainder of 0. You could go I divided by P is 0 and I divided by Q is 0. So you could do an ampersand, ampersand. But why not? Just go ahead and do the math in your head. 15, right? Except for it's not 15, it is what in this case? P times Q, right? Now, what happens when I get up to 15? It is divisible by 3, and it's divisible by 5. So would I ever get down to this block right here? No. I need to put the most specific case first, right? And so this one should be my first. If it's divisible by both, then print Fizzbuzz. Else if it's divisible by a P, then print Fizz. Otherwise, if it's divisible by Q, then print Buzz. Otherwise, if it's divisible by neither one of them, then print the number, right? GCC this. Let's check it out for, for the classical Fizzbuzz problem here. And what would you expect? 1, 2, 3 becomes Fizz. 4, 5, Buzz. 6 is divisible by 3 again, so we get a Fizz instead of 6. And then Fizz, the next Buzz that we get is 10 because 0, 5, 10, 15, 20, etc. The very first one that we get Fizzbuzz is 15. Where would the next Fizzbuzz be for 3 and 5? 30. Let's check. Fizzbuzz, yep. Next one would be 45. Okay, it looks good to me, right? Of course, you could always, try it with different values. I only want to print 1 through, or 10 through 50 with 2 different primes, say 5 and 7. All right, still works at least. Where would I expect Fizzbuzz to be printed now with 5 and 7? So 35? Looks like it works to me, and I don't see any other Fizzbuzzes as we go along here. And it started at 10. 10 is divisible by 5, so I get Fizz. Pretty happy about that. That looks to be a 100% right there. Right? 30 points in the can. Okay. You'll have to write a couple of functions involving arrays, just like you're doing for, hopefully you're done with it. But if you're furiously working on it now until midnight, then good luck to you. But we've been given a tester here, as well as a bunch of helper functions, and the signature's already done. Except that, oh yeah, we've already been given the documentation here, so yay, free points. Except for the header documentation, which I'll skip that. But we've got a bunch of functions here. Some of them are already written for us for convenience, printing out an integer array, printing out a double array. But here are the 3 functions that we actually have to implement. Right? Actually, only 2 functions, and then the third one was bonus. We'll go ahead and do that, though. Okay? I don't think I have any bonus on this midterm. There's bonus later on that I'll talk about after I've posted a pre-midterm grade milestone update. Okay? You'll write a couple of functions involving arrays. Let's focus on the first one here. It's called scale. What is its return type? A double pointer. So it's going to return a new array, right? It's not under any error conditions, we could only ever return null. We don't return true, false. We don't return an integer value. We return null for any error conditions. Write a function that takes an array of numbers and creates a scaled copy of the array. The new array will contain the elements of the input array, but each one will be scaled to the by a constant factor. So here's the input array. Why is it const? I'm not making any changes to it. You give me an array, I make you a copy that's scaled, and I give it back to you. I'm not going to touch your original array, and that's what the const is there for. There are n elements in the original array, and here's the factor. For example, if the input array is these numbers, so 1, 2, 3, 4, 5, 6, 7 numbers, and there's a factor of 0.5, then what we'll do is we'll make a copy of this, but each one of them will be scaled by 0.5. So we multiply 2.71 by 0.5, and we get 1.35, of course, rounding issues. Well, this is just being printed out here. 0 times 0.5 is going to end up being 0. -1 times 0.5 is going to be -0.5, right? So we're scaling it. If it were 2, then we'd be doubling it, right? Whatever that scaled factor is, we're simply going to multiply everything in here in the new copy, okay? For any potential errors, you should return null instead. So let's go ahead and, oops, I'm glad I didn't do that. There we go. Scale? Yeah, scale, okay. What's the very first thing I do? Error handling, error checking. What are the potential issues here? If this pointer that I've been given is null, if array is null, or what's another potential issue here? Yeah, it's the size is negative and is less than 0. Is there any potential issue with the factor? Could be 0, but that's okay. That means I just want a 0 array. I don't know. What else? I don't think that there's anything that would be wrong with double here. It could be nan or inf, but then you want to scale by nan or inf, that's your business, right? I'll go ahead and do that for you. I give you an array of nans, give you an array of infs, right? Infinities. Right? I'll return null. Come up here and make sure that I've included everything. Yeah, I did. I did that for you last year. Not necessarily going to do that this year, but you'll see. It's not been finalized yet, by the way. All right, so what's my next step? I need to create a new array in order to return it. So, actually, should I do an integer array? No, what's the return type? A double array. So, result is equal to a call to malloc. And I want to make sure that I cast it as a double array, not an integer array like you've been working with on Hack 5, except that in the second part, you've been working with a two-dimensional array of pixels. So anytime you call malloc, you're going to ask for how many bytes? However many bytes the things inside your array take. In this case, it's a double. And how many of them do you want? N of them. And then return result eventually. Okay. Now I need to go over and copy each element. If I just did a regular for loop here, for int I equals 0, I is less than n, I plus plus, that's that idiomatic for loop that just goes over all the elements in an array. And if I set result of I, oops, is equal to array sub I, I'm just copying over the result. I now need to scale it. So to scale it, it's just simply a matter of multiplying it by factor. And that's it. We're done. All right. We do have a tester over here with that same exact input that was in the handout. We call scaled result here with 0.5, and then we print it out to make sure that it works. Okay. Oops, clear this. GCC C array utils.c. A lot of questions about this for some reason on Piazza and Discord. I don't understand why, because you've been doing this now for the last 6 weeks, or at least the last 3 weeks. It's no different than your utility utils.c or and your utils tester.c. Right? You still compile it using the C flag, which produces a .o file here. That's arrays.o. It's an object file. Now to create an executable, GCC array utils.o and array tester.c, and then run it. All right. So these are not going to be correct, of course, because we haven't implemented them yet. But look, there's the original, and there's the output. Look good to you? Yep, looks good to me. Of course, now I hand it in, and if I get a segfault, then I start panicking. What's going on? I don't have the grader set up for this, so I can't hand it in. But we'll try to cause an error here in a second, and I'll remind you about how to deal with that. Okay. All right. So the next one. Write a yep, there we go. Write a function that takes an array of numbers, in this case integers, and finds the minimum and the maximum values in it. So we're actually returning 2 values, just like you returned 3 RGB values, or you returned 4 CMYK values. You can't return multiple values. Instead, the way that you do it is through two pass-by reference variables. So we're given this array here of size n, and we communicate the minimum value back through this method, through this variable here, and the maximum value through this variable right here. We do have an integer here that's an error code, right? Once found, the minimum maximum value should be reported using the two pass-by reference variables. For example, if the output array is this, then the minimum and maximum are -5 and 21 is the maximum, respectively. And so the two pass-by reference variables would be given these values. For any potential errors, you should return a non-zero error code here. So here we weren't looking for a full enumerated type. You can just get by with zeros and ones. Okay? All right. Where is it? Here we go. Here it is. Get MinMax. So help me out. I'll iterate through the array, of course. Int for int I equals 0. I is less than n. I plus plus. I'm going to look at the ith element, and if it's less than the minimum that I found so far, then I update the minimum. If it is greater than the minimum, the maximum that I found so far, then I update the maximum. That means that I need two variables to do that. Int min, int max. What should I set them to in order to start the whole process? Oh, I could do I could do 0, but then what if the minimum? What if they're all positive values, and then the minimum happens to be 1? Right? Then that'll fail because I'll never find anything smaller than 0. So let's initialize it to something that's actually in the array. The first one. Array of 0. But what if there is no first one? What's the first thing I should have done? Error checking. And guess what it's going to look like? Very much like this. That takes care of array, that takes care of n, but what else could go wrong, potentially? Min val, value is null, or max val, value is null. Right? All of those things could go wrong, and in this case, we don't return null. Why? Because that's not a pointer. Right? That's an integer. So in the event of an error, return a non-zero error code. 1, 42, whatever your favorite non-zero number is. I'll just go ahead and go with 1. Right. Otherwise, I do know that there is a first element. In fact, I could say, well, if it's 0, then no, that doesn't make any sense either. So there is no minimum. Right? If there are no elements, then that's a corner case that there's no minimum there. Right? So I'm not going to do anything with those values. But if there's at least 1, then I know that these two lines are safe. Okay? Otherwise, go through the rest of them. If array of I is less than the minimum found so far, then the minimum will be updated to array of I. If the array of I is greater than the maximum found so far, then the maximum is equal to array of I. And I do need two independent checks here. It's not an if-else if because these are two independent things, right? That I need to check: is this less than the minimum that I've found so far, or is it greater than the maximum that I've found so far? Right? Obviously, sometimes both of these can't be true, but I don't know which one is true or false. Right? If I've initialized this to the first one, I could be clever and do what? Start at the second one instead. Okay. Go ahead and be clever. It doesn't buy you anything that much, but I'll go ahead and be clever and do that. Okay, I found the minimum. I found the maximum. What do I need to do to communicate those values here? Min value is equal to min, and max value is equal to max. Is that correct? Min is a regular old integer. Min value is an integer pointer. So what do I need to do to make this integer pointer into a regular old integer so that I can put something into the bucket? Dereference. Dereference. And then everything went right, so return 0. Let's try compiling and see if this works again. Oops, I need to compile both. There we go. What would the array tester do? Okay, there's the input array from the handout. We should expect what again? Oops. We should expect -5 and 21 if we're correct. Hey, all right. Cool. Let's go ahead and do the bonus before we do other stuff here. Here's another one, closest values. Write one more array function in the same header file as follows. Given the input array, so here's the array, here's its size, and we've got these two pass by reference variables. It should find the two elements in the array that are the closest to each other in value. For example, if the input array is this, then the two closest values would be 3.15 and 3.14, which are only 0.01 difference away. Now, a negative value that's -3 and +3, that's 6 away, right, in absolute value. So you have to be careful. You can't just, take the absolute value. You can take the difference, but you don't know if this is positive, this is negative. So you have to take the absolute value of the difference between those to find which one is the closest. Right? Report the indices of the two closest values using index A and index B. Okay? So for example, this one, I should report index 1 and index 3, right, respectively. The function should return a non-zero error code for any potential errors, 0 otherwise. You'll need to write your own testing code because we did not provide that here. Right? But it's great because we actually have the input right here. Let's go ahead and write the testing code. Right? I would want two indices, so int index A and index B. Right? And then also the value? No, I can get the value from the indices. Right? And the name of the function was what? Closest values. Right? So int error equals closest values. We'll pass in A, N, and our index A and index B. And why am I putting ampersands in front of them? They are regular old integers, and it expects integer pointers. So to take a regular old integer and make it into a pointer, you put the referencing operator in front of it, the ampersand. Okay? Now we should report printf closest values at indices %d with closeness value of, I don't know if that's what you'd say, with a difference of. There we go. With difference of. And then I could go ahead and put in index A, index B, and then absolute value of array. Is it array? AR? No, A, sorry. A and index A minus A and index B. Is that correct? Abs. If I've got two double values, remember these are doubles, should I be using the absolute value function, or should I be using something better, something more fabulous, right? Fabs. There we go. All right. Well, if I do this, I'm not going to get any results out of this, right? Oops, not A. What is it called? Oh, input. There we go. I did it up there, though. Okay. Input. And it's a size N, 7. Okay, they were both 7, so we're good on that one. Clear. Oh, okay, fine. Not A, it's input and input. There we go. All right, good. And again, I haven't actually implemented it yet, so 0 and 0 with a difference of 0. Let's implement it now. Of course, basic error checking. If array is null, or n is negative, or index A is null, or index B is null, then return what? What's the only thing I guess that this is just an error code. So I return something went wrong, 1, 42, -1, whatever you want. Right? Otherwise, at the end, you return 0, right? No error. All right. How do I go about finding the actual lowest, closest values? If I only compare those that are standing right next to each other, so if I only go through it once and compare the first one and the second one, I'll get some value. Then I'll compare these two, and I'll get something that's larger because it's going to be at least 8 value difference, whatever you want to call it. If I compare this one and this one, it'll be even more difference. The difference so far is like only what? 293.44 between these two. Well, the difference here is going to be 1. The absolute value of difference here is going to be huge, 122 something. So I would end up, if I only went through it once, I would end up saying, well, these two are the closest. But is that the correct solution? No. What do I need to do? I need to take the first one and compare it to all the others. Right? And find the first one and whatever other value give me the closest value. Then I need to save that off and say, well, that's the closest I've found so far. And then I need to go to the second one and compare that to all the others. And if I find something, a pair that's even closer, then I need to update this closest value over here, right? As well as the 2 indices. Keep track of those. So what I need to do is I need to do this for every pair. And if I'm going to do this for every pair, how many loops am I going to want? 2. Oh, it already did that for me. There we go. I will iterate over for each element, for the first one and the second one and the third one and the fourth one, for int I equals 0, I is less than n, I++, idiomatic for loop. Now, think about looking at the ith element. Everything previous to that would have been compared already, right? Why? Because, well, when I went for the first element, I would have compared it to this ith element over here already. I need to compare it to everything else remaining in the array. So I will create another variable, int j, start it where? I+1. Why not I? If I take the difference between 5 and 5, then I'm always going to get 0. I don't want to compare things to themselves, right? So I+1, I is less than n, or j is less than n, excuse me, j++. Now be careful here. What's going to happen on that last iteration when I is equal to n minus 1 and j is equal to n minus 1? I will be comparing it with itself. So to stop that, I will stop short by 1. That's how I would write it. If you want to write it another way, that's perfectly fine. Here's an alternative. If you just want to brute force this, int I equals 0, I is less than n, I++, for int j equals 0, j is less than n, j++. Just go ahead and do for every single pair. You're going to compare A to B and B to A, so you're going to be doing double the amount of work. That's fine. But you want to make sure that you're not comparing something to itself, because 5 minus 5 is always going to give you 0. You can't get closer to than 0. Right? So if I is not equal to j, then you go ahead and do your logic here. Right? That's another way that you could have done it. You could have gone backwards if you wanted to. You could have done it with while loops if you wanted to. I'm going to go ahead and go with this solution, though. Right? What do I need to do? I need to compare, what's the array called? ARR sub I and ARR sub j. Right? If the difference is less than the diff found so far, then update the minimum difference and update the indices. Right? Okay, I just wrote it out in plain English. Right? So how do I compare the two? The difference of the two. Erase of I minus erase of j. But I don't know if they're positive or negative or whatever. What do I want to do? I want the absolute value of the difference. But these are doubles, so I need fabs. Right? And if that is less than the minimum that I've found so far, min diff, meaning that I'm going to have another variable up here, min diff. Right? What do I initialize it to? Let's come back to that. If that's less than what I've found so far, then I found two closer values. So I update min diff to be this value. And I need to update indices. I'll just do it directly here. Index A is equal to I, index B is equal to J. If you want to create two other variables and then set them down here, that's perfectly fine too. Right? But this is quicker. Okay? What do I initialize that min diff to? Could I do 0? Nope, because now nothing beats 0. I can't initialize it to something else because if nothing beats 0, then nothing beats negative. Right? I could do like something very large, like 1,000,000, right? But if I gave you an input where the minimum difference was actually 2,000,000, then this would fail. So what could I initialize this to? Something sane. Well, why don't you just take the first two elements? If I take the first element and compare it with itself, then I'm going to get 0. So I want to take the first two elements. That makes me start rethinking this error up here. Right? Can you, is the minimum distance between two numbers defined if you only have one number? No. Is the minimum distance defined if you have no numbers? No. So I'll just say that if it's less than 2, that's bad. Right? That's bad data. We'll just return an error code. Otherwise, now this is safe because I'm guaranteed that there are two values in here. Okay? All right. Let's try to compile it. See if I've gotten any compiler errors here first. Nope, good. Oh, okay. And what should I expect? I should expect a difference of 0.01 at indices 1 and 3, I think it was, right? 1 and 3. Yay, I got it. And of course, you can go back over here to the tester and try a bunch of other things. Ah, come on. Don't hit the back button. Luckily, it saved it, and it'll open up here in a second. But I don't have any other testers besides this, but I'm reasonably assured that all these values are good. All right. Okay. So let's screw something up. Maybe we didn't. Maybe we weren't as good as we thought. Maybe we didn't do any basic error checking here. And so when we try to call scale here, let's go ahead and double test array. But I won't initialize it to anything. I'll call scale on test array of size, I don't know, I meant to put 10 things in there, but there's nothing there. And a scale factor of 0.05, or 0.5. There we go. And then, of course, double result is equal to. There we go. That looks good. Let's go ahead and try to compile it again. It should compile. Oops. I want to compile that first, and then this. Segmentation fault. Why is it giving me a segmentation fault? Well, you saw it. Why? Why? Because I intentionally removed the error checking. But if I didn't know that, what's my only recourse here? What's the first thing I need to do? I need to find out where is it segfaulting and why is it segfaulting, right? In order to fix this problem. So I'm going to go ahead and copy everything over to CSE and open up. What was the tool that we looked at last week? Oh, and GDB, right? GDB, SCP. There is probably which GDB? All right, there is a GDB here, but it's going to look ugly because I'll only have this little tiny area down here in which to work. So what I'm going to do is I'm going to secure copy all of my stuff, everything that begins with an array, to my account over on CSE. I'll just do it there. Oh, don't tell me you are firewalled. Huh. Okay. Apparently, Amazon Web Services Docker instances are somewhat firewalled off from the rest of the world. Fine. I will then download everything over here onto my desktop. Oh, you can't drag and drop? Okay, fine. Oh, you can't download multiple files? Download. Save it. Download. Save it. Download. This is stupid. Save it. So what? Oh well.
You have to rename the file every time you download it again.
There. I want to make sure I stay in frame here. I'm not sure what OBS is recording. Okay. All right. So I've got it in downloads. Hey, there's everything. All right. Now I'll SCP everything, array, into CSE or C at CSE. There we go. I don't have GDB installed on my computer. That's why I'm going over to CSE. All right. All right. Move all the array stuff into demo so we have a nice clean directory there. There. Make sure that it's there. Now I'm in frame. I already had a demo apparently. Move array tester into demo. So I'll go into a demo of a demo. There we go. All right, how did I compile all this stuff again? GCC G arrayutils.c, GCC arrayutils.o, and array tester. Run it, and I've got a, oh, okay. It's fixed now? Haha, all right. That's because I think you're right. I think I downloaded the copies and I uploaded the original. Ah, darn it. Really? No, we implemented all this stuff. Okay. And scale has been, all the error checking has been removed. But this stuff right here was not in the array tester for some reason. MinMax array tester. Maybe I didn't save it. No, it's right there. Huh. Okay. I'm not getting a segmentation fault here. The compiler is compiling it away intentionally. Fine. There we go. I forced it to have a segmentation fault. All right. Now we're good to go. First of all, am I going to be able to debug the way that I compiled everything? Nope. What do I need to do when I compile something if I want to run GDB? I also need to compile it with the G flag. And the G flag on this one. And again, The reason that you want to do that is because it preserves line numbers and function names and stuff like that. If you don't compile it with the G flag, all that stuff is compiled away, and it just gives you these mysterious memory addresses instead that you'll never figure out. All right, A dot out. When I run it, segmentation fault. So GDB, A dot out. It started up, text-based user interface. Layout, next. Of course, it's not going to run it, show anything because it's not running yet. And let's go ahead and just run it. And it tells me automatically that there is a segmentation fault at this line. Remember that you can, it's kind of screwed up right now. You can always hit refresh or type refresh. And there's something wrong here. What is wrong? If I start printing stuff out, well, what's in the array? Oh, hey. That's a memory address that is not valid. It's the 0 memory address, which is null. How big was it? Okay, well, if I tried to print that out, oops, then cannot access memory at the null pointer location because I passed in null. So let's back up, quit, or not quit, but let's break at the main and run. What happened up to this point, right? So next, 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 refresh. I'm about to call, and of course we see immediately here that it's null, and I never initialized it or anything. But I'll go ahead and I don't want to, I want to go before that segmentation fault. So if I hit next, it's simply going to try to jump over that line. So if I want to go into that function to see what's going on, let's go ahead and hit step. Step into that function. And now I'm in that function. Let's go ahead and list the inputs that we got. Print array, and of course we get a null pointer there. Print n, well, there are supposed to be 10 things in there. Print factor. And okay, we received that one correctly. Next, next. And at this line, when I try to dereference that first value there, print I, the erase of A0, that's when it occurs. Next. So I know that it's happening at that line. I didn't need to walk through the program to find that out. I just needed to run the debugger, and then, of course, when it sends the segfault signal, it tells you what line number it's at. But then I can use the debugger to, well, stop right before that line so that I can see what's going on. Right? I can stop at break array utils .c at line 28, right? And then rerun the entire thing. Of course, I still have that breakpoint starting at main. I'll just continue on to that next breakpoint, and then I can do it all again. Print, ignore that. I don't know what that is. What was it? Print n, print array. Oh, now I've got n. Oh, because I called it once before, remember? I called it on the legitimate input. And so I can look at, oh yeah, the array is correct. Print array at, or array, and how many are in there? 7. Okay, I received that correctly. This is not 5.3 because floating point errors, not everything is representable. And print factor, okay, 0.5. You can walk through this to see what a successful run looks like. Print result at 7. You know, you can see it. It's filled up now halfway with the results, and it still has these 3 yet to do. So if I keep going, then right before I return result at 7, right? And I see, okay, now it's done. That worked. Well, then continue to the next call to that function, and of course now I've got the bad input, the null pointer that I gave it. Right? Again, if you've got a seg fault, you need to be able to reproduce it, and you need to run it through a debugger. If you ever ask us what's going on with that seg fault, that's exactly what we're doing to find out, because we have no idea unless we run it. And of course, the only way that you can even start to run the debugger is, one, you have to know how to run the debugger, so make sure that you're watching lecture from last week or module 8 stuff. But of course, you also need a reproducible test case. It runs fine on my computer because I only tested easy stuff. Right? I only tested what was in the handout. Right? What about all those edge cases? What about all those corner cases? What about error handling, right? You need to be thoroughly testing in order to be able to reproduce an error so that you can then go and dig down deep and find what's wrong with it. Okay? I don't. Hopefully this recording was successful. Any questions before I try to put it in the can and upload it? No? All right. Remember, you have all day on Wednesday for your midterm. There is no lab tomorrow because to give you time to prep for the midterm. The best prep, of course, is going over your old hacks, making sure that you have 100% on your hack tonight if you haven't already. Because as you've seen already, there are going to be array exercises on your midterm. Okay? All right. Hopefully this worked.